Welcome back. Today's lesson is on solving one-step equations. What is the difference between an expression, which we've been talking about in class, versus an equation? Well, an expression could look something like 5x minus 3, okay? Where x is our unknown, we use it as a variable. An equation could be 5x minus 3 equals 9. The main difference is an equation contains an equal sign. What we are going to be doing in this unit is taking one-step, two-step, and multi-step equations and learning to solve them. Let's take a look at these three examples. For A, we have x minus 5 equals negative 1. Our goal whenever we're working with an equation is to get our variable alone. It's all about keeping your equation balanced. This x minus 5. To move negative 5 to the other side, we do what it's called the inverse property. The inverse of negative 5, or opposite, would be positive 5. So we are going to add 5 to each side. I'm very particular on how I set up this format because I don't want you guys getting confused later on down the road. So I do everything down in this order. So negative 5 plus 5, well, that cancels out. That was our whole goal. So we're left with x on that side. So x equal, what is negative 1 plus 5? The signs are different, so we subtract and keep the sign of the bigger number. So we get x equals 4. So you're probably asking, okay, that's great, but what does that mean? So when x is 4, if we plug that back in to our original equation, so 4 minus 5, does that equal negative 1? Well, 4 minus 5 is negative 1. Hey, it works. That's the whole point. Let's look at another one. So this time we have z plus 3 halves equals 1 half. So even though there's a fraction, don't look at it as anything more complicated. This is a z plus a number. So to move a positive number to the other side, we do its inverse. So what's the opposite of positive? Negative. So subtract 3 halves. Bear with me here, my stylus is at school and I'm sick home working on this. So we subtract 3 halves from each side. Z equals, well, what is 1 half minus 3 halves? Back in our rational unit, we did these. This is positive 1 minus 3, or negative 2 over 2. So z equals negative 1. Okay. And our last one, let me erase that here. Our last one is y plus minus 10 equals 2.3. Decimals, integers, not a big deal, but the opposite of this negative sign is to add 10 to each side. Just like so. So we have y equals, well, what is 10 plus 2.3? 12.3. And you can always check to make sure you're correct by taking your y value of 12.3 and plugging it in wherever you see a y. Just like when we did evaluating expressions earlier this year. So 12.3 minus 10 is indeed 2.3. Let's look at an application of this. A company has a profit of $750 this week. This profit is 900 more than the profit P of last week. Which equation can be used to find the value of P? So there's a few key things that you want to point out when you're working with a word problem, and it's the key things that mean things in math, like we did earlier in class. We talked about what words translate to math. So what stands out to me right off the bat are things like more than. And what does more than mean? Well, that means addition. So $900 more than the profit last week. So before we do anything else, what doesn't match with that? If we look at A, that's 900 minus P. Well, that's not the same thing. C, 900 equals P minus number. No. And if we look at B, we have P plus 900. Okay, that looks promising. And then D is P plus 750. Okay, that doesn't look promising. Just based off of that information, we know that it's going to be B. But let's explain what the word is means in math. You may not have remembered this, but is always means equal to. So this profit of 750 is equal to 900 more than or plus the profit P. So when you're trying to translate something, it's just looking for those keywords like more than and is. So our answer would indeed be B. They're not asking you to solve it, they just want you to find out what equation would work. Okay, let's look at some different scenarios. Before we worked with addition and subtraction only. These next few examples will be with division and multiplication. So let's look at A first. We have x divided by 3 is equal to negative 6. They could have written x divided by 3, but we learned in our previous unit that they usually write it as a fraction for us. There's a reason for that. It's just easier to work with it. So when it's x divided by a number, to get that number to move to the other side, to get the x alone, remember that is our ultimate goal, the opposite of division is multiplication. So we are going to multiply each side by 3. So we get 3x over 3 equals negative 18. Now these 3's, they cancel. I just wanted to show that step so if things were more complicated you could see it. So we get x equals negative 18. Let's look at part B. 18 equals negative 4y. Negative 4y is the same thing as saying negative 4 times y equals 18. It doesn't matter that the variable is on the right-hand side now, or if it's on the left-hand side. Your goal is still to get that variable alone. So how do we get negative 4 times y alone? Well, it's being multiplied, so the opposite or the inverse of multiplication is division. So take that negative 4 with it to each side, and we get y is equal to 18 over negative 4, which reduces down by 2. So we get negative 9 over 2, or if you wanted the decimal, it doesn't matter to me. Sometimes it's easier to see it that way. Negative 4.5. Okay? Our last one for this little segment here is negative 1.5n equals 3. So again, a number next to a variable means to multiply. So make note of that there. Means to multiply. So the opposite of multiplication is division. So when you're first learning to do these equations, the easiest thing I found from students in the past and for myself is I always ask myself, what is happening? If I'm clear in the understanding of what is happening, I know I just have to do the opposite. Just like I know this number is being multiplied, the opposite is division, and I set it up that way. 3 divided by negative 1.5 is negative 2. Remember, a negative divided by a positive is still a negative. There you have it. So let's continue on. Again, let's try an application. The record low temperature in Arizona is 1.6 times the record low temperature in Rhode Island. What is the record low temperature in Rhode Island? So if you look at our diagram over here, this picture, right? This is the temperature in Arizona. We have a reading of negative 40. So negative 40 is equal to 1.6 times the record load in Rhode Island. So I'm going to use an R for Rhode Island, and it's times. So the number and the variable can stand next to each other like that. We try to avoid using an X for times because it looks a lot like the variable X. So 9 times out of 10, you're just going to see the number next to it like that. So what is the record low temperature in Rhode Island? We have this equation now. Is that something that we now know how to solve? How do we get the 1.6 and the R to separate? Well, they're being multiplied, and the opposite of multiplication is division. So divide by 1.6 to each side. And in your calculator, you can plug in negative 40 divided by 1.6. We plug that in, we get negative 25. So make sure you're following along with your calculator as well so you can get the real effect of this. You don't have to put the negative in the calculator, just remember that a negative divided by a positive will give you a negative result. So the record low temperature in Rhode Island is negative 25 degrees Fahrenheit. We always want to make sure that we answer the question after we solve everything. In Rhode Island. Okay. The last thing we will be talking about today is using a reciprocal. Remember, a reciprocal, if you had something like 2/3, let's put this down here for notes. So 2/3. The reciprocal of that would be 3/2. So you just flip the fraction. Now, I will show these two examples in a different way. I'm more of a fan of doing it in 2 steps, but that's just my preference. So if we have negative 4/5 times x equals negative 8, we can take the reciprocal, I'm just going to write it bigger here so you can see it, and multiply by negative 5/4. So I just took my fraction and I flipped it over. So our 5's cancel, our 4's cancel, and we're left with just an x equals, what is negative 8 times negative 5? Positive 40 over 1 times 4 is 4. So x equals 10. That's one approach if you like doing the reciprocal. If you find that confusing, what you can do instead, and we'll look at this other example here, you can multiply each side by 8. So I'm getting rid of the denominator first, and that leaves me with 3h equals, what is negative 9 times 8? Negative 72. And then 3 times h separates by dividing by 3. So h equals negative 24. Now, it's really personal preference. When I'm introducing this in class, I tend to stick to the method in B, but if you are comfortable with your fractions, method A is easily attainable. So that is solving an equation using a reciprocal. What I want you to work on now is the on your own in your packet, match the operation with its inverse operation, and solving those 5 equations. When you're finished with those, come see me and I can tell you whether to move on to Go Formative or if we need to work on additional practice.